Welcome to the joy of coding.
Hello and welcome to episode 65 of The Joy of Coding. My name is Mike Conley. We're going to be exploring some Firefox code today. I hope you're excited. I'm excited. It's going to be a great day. Let's get down to business. Whoop, here's my screen. Whoop. Whoops, that's my life. Hold on a second. What am I trying to show you here? Yeah, here we go. One sec. Let's see. So here's the agenda. It's not exactly, well, let's see. There's not a whole lot of bugs on here, and there's a reason. I'm about to explain. Just 1 second. So, first of all, I'm recording. My volume is working. Sounds were working. Okay, we're good. So what I'm hoping to do today, actually, is I'm going to make today a special episode of The Joy of Coding, where we're going to explore some of the implementation of service workers in Firefox. Now, service workers, if you're not familiar with them, are this new technology to make it easy for Firefox or web applications to communicate to servers, even when you're not viewing the tab. The tab might not even be open, but they can like spawn a service worker and they can keep running in the background to do various things. So that's what I'm hoping to look at today. I've never looked at the code before. I'm going to be starting from scratch, and so we'll take notes as we go. But I also want to report that that stuff we've been working on for like a month and a half, that patch to make the initial browser remote sooner if we're defaulting to using remote, we want to make it default to remote tabs. That stuff landed. It landed earlier this week, and so far it has stuck the landing, so I'm pretty stoked. So pretty happy about that. Um, so there was that piece of news, and if it turns out that the service worker thing doesn't work out, because sometimes it doesn't, the like no plan survives breakfast, then you know, I can move over to this bug that I've been working on in the meantime. Now I should point something out. This is for the new people who are watching. The others who've been following along, you already know this, but there is this agenda is sort of a very basic outline. This thing we're looking at is a basic outline of what I hope to do during the episode. Things might go wrong. I might get off track, but some of the things in this list might actually be useful. Like there are links in here, stuff you might want to know about, and so there's a copy of this agenda available to you. If you go down to the additional links section, if you're watching this on Air Mozilla, there's an additional links section, and there should be a link to this agenda that you can click on the links and check stuff out. I'll be updating it as we go, and then like once it synchronizes, like that little spinny turns, you just reload the page and it should have all of the stuff that I've added. So one of the things I'm going to add right now is a new note. I'm going to add a new note called BKAG learning about service workers. This is the second time I've done this Better Know a Gecko thing. The last one I did was about learning about the async tab switcher. That was way back in January of this year. So this is a new one. Better Know a Gecko service workers. I'm going to get a public link to this note, and I'm going to drop it right now into the agenda. So now if I sync and if you reload, you can follow along with my notes as I add to them. Okay, so where do we begin? Where do we begin by like understanding service worker stuff? Well, there are a couple of different ways we could explore and try and figure out the implementation. There are like let's see. Whenever I'm trying to find an entry point and like a way to get started exploring a thing in Firefox, I often like if it's a front end thing, if I'm like trying to figure out where is this front end thing being implemented. Usually the trick I use is to like copy a string that's in the UI and then like search for that string, and it's usually like there's like a translation key value thing that we use, and so there'll be a key value for that string. I'll find that key value, and then I'll look where in our code that key value is used, and that's usually my entry point into exploring the code base if I'm not familiar. And in this case, service workers mostly run in the background. There's a little bit of UI, but like for the most part, it's a DOM API that does a lot of cool stuff. I'll give you an example. Um, so I'm at this website, Service Worker. I'm gonna put this link inside my note. Service Worker demo page. I'm also going to bump up the font, Service Worker demo page. So it's this very clever URL, serviceworker.rs. And there are all these different things that you can demonstrate. And these like colors represent the difficulty of the, like from the perspective of someone who's writing something against this API. So for example, let's look at message relay. So this recipe shows how to communicate between the service worker and a page and shows how to use a service worker to relay messages between pages. So what's this demo? So service worker status supported. Open another window with this page. So I'll click on this. So, and it just crashed. Oh, the irony. The irony. Okay, so I'm going to restart my Firefox. I'm going to submit that crash report because I'm a good nightly user. I'm going to restore my session. And now this tab crashed. Oh, holy smokes. What's going on? I have an unsubmitted crash report. Everything's crashy. Alright. Well, that's what happens when you're dealing with nightly software. Let's go to about session restore. Is that going to work? Yeah. I'm going to restore. Okay, so let's try that again. I'm going to open up a window here. And now I'm supposed to type some text in below to post message. So like, hello, other window. And now, oh, client says hello, other window. Great. And then I can say test 1, 2, 3. Yay, and that was sent to me. Now, my understanding is that that's not totally impressive if this link we're using like window.open and so that there's like an opener connection. But we're using just a standard like anchor link with target underscore blank. So this isn't using opener and post message between like a window with which we can fully control. This is like if I had visited this page by like going away and just going to this URL, I'm pretty sure that the same thing will work. Like test 1, 2, 3 again. Is that gonna work? Maybe it doesn't work. Oh, that's because I went to the supported. Hello? Hello? Client says hello? Maybe I don't fully understand this demonstration. Another test. So like it does look like clicking like the window, maybe it's restricted to the window. Maybe that's it. Like if I go to this page here, can you hear me? Does that show up in the first one? Hey, it does. So it seems to be restricted to the window. That's interesting. I don't know if that's on purpose or not. Oi, can you hear me? Interesting. Okay, so the upshot is, or the lesson there is, I didn't have to use window.open to open the window, and that's useful because sometimes a user will visit a page not under like, and as a web developer, they didn't click on your window.open link. Maybe they visited it through another like another way. Maybe they clicked on a link on Yahoo or Google or Bing or whatever, and they got sent to your page, and they already have your page open in another tab, and then you can do communications between the two windows. Now immediately there are potentially evil things one can do with that. I hope not. Like they can. I hope like tracking is not a thing that I don't know if service workers like consider that. I'm certain that the people who work on this at Mozilla have that in mind. We definitely care about that sort of thing. So I trust what's going on here. But service workers are also very new. And so we have this thing. And how did this work? How did this demo work? If we look inside, so there are two files that this demo is exposing. One's called index.js. Oh, this is very nice. They've got these like super uh, super documented demos here. So we check to see if there's this service worker property on the Navigator global. And then we call things on it, like register. We call register and we pass it some script. And then we add an event listener for messages from that service worker. Okay, that's pretty straightforward. And then the service worker.js that loads, we add a message listener, excuse me, and oh, it looks to get all of the connected clients and forward the message along. So we can get all of the clients that have loaded this service worker, and then we can like post a message. Whenever we activate, we will wait until I don't understand. Immediately claim any new clients. This is not needed to send messages, but makes for a better demo experience since the user does not need to refresh. Interesting. Print a warning to users playing with the demo are confused. So I think my entry point is going to be that service worker global. This thing, service worker off of Navigator. Let's see where that's defined. Now, my understanding of how Navigator, what I'm going to use to explore this, I'm going to use DXR. I could also use SearchFox. They're both quite good, but I'm going to use DXR for now. Let me pump up my font a little. So there's this thing called service worker. Oh, the other thing that, like another entry point would be looking at, like there's a pref here for enabling and disabling service workers. That would give me a great entry point. Like knowing that is usually a good indicator of where the master control is. Because you usually put your enabling and disabling somewhere in the main entry point of the component that you're enabling and disabling. Excuse me. So there are a lot of hits here whenever I look for service worker. And a lot of stuff here under DOM, which makes sense because it's a DOM API. And there's some stuff for Canvas, which I don't understand. IndexedDB, aha, notification storage, some IPC stuff, I'm guessing for E10S compatibility. And a bunch of tests. And then here we go. Here's where we've like defined what's on Navigator, the Navigator Global. This web IDL is what we call them. And so what we do is we've defined this thing called Navigator. It's using the partial on the interface Navigator, we're adding this service worker read-only attribute, and we make it available if the service worker container is enabled. I think we call this function to check to see whether or not. That's my guess, is that we will call this function to see whether or not to even make this available. And I'll bet that is enabled, and now I'm using SearchFox. Now that is enabled function is here inside the service worker container, right? And I think that's what service worker is going to refer to. Whenever you call navigator.serviceworker, it sounds like it's referring to the service worker container, and that's what we've got here. So this to me is starting to sound like the sort of big kahuna. And when we check to see if we're enabled, we assume we're on the main thread, like we better be on the main thread. We're being passed a JS context and JS global because we're being executed from JavaScript. And we try and get the window from the global, so the window that's currently running this script. And we check to see whether or not the service worker is enabled. It looks like if we're in private browsing, if the dock is in private browsing, so service workers do not work for private browsing windows, is what this is saying to me. Because if the doc is a private browsing window document, we return false here. So service worker is probably not even available. If I go to a new private window, I wonder if I go like to the CBC, and then in here, if I go navigator.serviceworker, it's not even available. It's undefined. Can you even see that? I hope you can see that. Let me trash this stuff. Service, navigator, service. Oh, you can't. It's still cut off. Navigator.serviceworker. Undefined. But if I do that in like this window, which is not private, we get navigator dot service worker is defined. It's this service worker container thing. So that's that's useful information. Um, so here's what we've learned so far, and I can write this down. Service workers are not enabled for private browsing. Window for documents and windows that are in private browsing mode. That's neat. And that's controlled here inside the service worker container. I'm going to get a permalink to this line just for like posterity's sake. We'll get a permalink, and I'm going to just link that up. Okay, that's neat. And then we check to see if it is enabled, and if it is, well then I guess we make the service worker container available. So what is this service worker container? What is this thing? So this is not a very big C++ file. It's what, how many lines? 340. A bunch of it's like headers and boilerplate for XPCOM stuff or cycle collection. I'm not sure. Not XPCOM, but just like cycle collection. And so whenever I explore a C++ file, usually I start by looking at the header to see like sort of a breakdown of what I'm dealing with. Which is, I think, what compilers do as well. So, a service worker container, we don't let any, this final means that like you can't extend it anymore, I think. It implements the DOM event target helper. I don't know what that is, but a DOM event target helper is something that is an event target, and it has like, it's to make it so that you can add event listeners to the service worker. I think it's like a mix-in for making it possible for a thing to like, you can have it listen for events and stuff. That's how I'll interpret it for now. So we've got the is enabled static, and then we've got this, we have a constructor, it looks like here. Then we have something called wrap object, and we have these register and get controller. You know, the other thing I should probably look at is the service worker documentation on MDN. Service worker API. Let's see. So there are all these. I'm not going to read all of this stuff. I think I've read it before a long time ago, but I want to look more at the interfaces that are available to the service worker, or specifically navigator.service worker. It's a read-only property. It returns the service worker container object. Whoa, this is an experimental technology, so be careful. Okay, so there's a controller which returns a service worker object if its state is activated. Okay. There's also a ready state, defines whether a service worker is ready to control a page or not. This API returns a promise that will never reject and will eventually resolve to service worker registration. On controller change. Whenever a controller change event occurs, I don't exactly know what that means. On error, so these are like standard event handler things. On error, on message, and then you can register. You can create a service worker registration using register. That sounds like a big deal. And then get registration gets a service worker registration object. I don't know. I don't know what that is. Was a service worker registration? I thought when you register, you're just passing like a path to some script, but maybe that's not the case. Maybe you can pass it like a function. I don't know. And then get registrations returns all service worker registrations associated with some container. Okay. So when you register, you pass in, like I said before, you can pass in a script, and then you can pass in a scope. I don't know what that means. And it returns a promise, and you call then on the promise, and then you check to see what the controller is on service worker. And then you can say, yeah, service worker is currently handling network operations. Or you can say, please reload this page to allow a service worker to handle network operations. Sometimes I guess the controller isn't there, and then the service worker is not properly controlling network operations until you reload, is my interpretation. Things can go wrong here if the promise fails to resolve properly, if it rejects. And in here, if there's no service worker, then I guess we do like a fallback. And we link people to the service worker FAQ at chromium.org. Interesting. So let's look at registration, because that seems like the first step whenever you're doing some stuff. The register method of service worker container, I'm going to pump up the font again, creates or updates service worker registration for a given script URL. Now I know I said I was going to explore the code base, and I'm actually reading a lot of documentation right now. The reason I'm doing that is so that I kind of understand a little bit of what I'm trying to explore. It's the equivalent of like looking at the welcome map just before going into a forest. You know, like maybe you've seen like there are trails, and don't worry about this area, there are no bears, but there are bears over here. Like, this is my equivalent of doing that. So you pass in a script URL, and then you pass in options. An options object to provide options upon registration makes sense. Options are a USV string, so I'm guessing, I don't know what a USV string is. USV string corresponds to the set of all possible sequence of Unicode scalar values. What happened?
Hey, what happened?
Maps to a string when returned in JavaScript. Usually only used for APIs that perform text processing and need a string of Unicode scalar values to operate on. What? I don't understand. This is usually... Oh, okay. This is usually... What range of URLs a service worker can control? I see. This is usually a relative URL. The default value is the URL you'd get if you resolve .. Okay. And it returns a promise. So let's look at how registration works. We'll just do that to start. So there's that register method, and then it's taking a script URL and then the options. And I guess if things go wrong, we can pass our error result here. Although I don't know, like that's interesting. I don't know why we would. Wonder what that's for if we're just gonna like reject a promise if things go wrong. But we'll check it out. Let's check it out. Register. Okay. So now we're looking inside the register method. So looking inside service worker controller dot register first. So what's going on is first we create a pointer, a smart pointer to a promise. Just the pointer. We haven't actually created a promise yet. Then we get what's called the service worker manager, and this is a thing that's implemented using XBCOM. You can tell because we're using an NSCOM pointer. And we get it using Mozilla Services, which if you've ever written front-end code, this is the equivalent of services.jsm. Get service worker manager. And if things... Oh, interesting. So I guess if things go horribly wrong, we don't return a promise. We will throw. Okay. So it sounds like this function register, because I'm saying that because of this. And what I'm interpreting this as is you can call register and you can pass it some stuff, and sometimes that'll work, but in some cases, in like the worst case scenario, like for some reason we can't get a handle on the service worker manager for some reason, maybe you've built Firefox without that component, then the function when you call register will throw immediately. It will not return a promise that you can check for resolving or rejecting. It will throw immediately. That's interesting. And we return null. And that's how I know that like it's not going to reject a promise. We're returning the null pointer. We don't even hand back a promise. Okay, so once we've determined that we've got the service worker manager, here we get the base URI, or we create a pointer to a base URI, and then we're getting the entry document. What is get entry document? Get entry document. Where was I just now? Get entry document. So that's a handy dandy function that is exposed to us somehow from DOM script settings. So I guess what it's going to do, I mean, it's pretty self-explanatory. We're getting the document that called the service worker, or called register, I guess. And then we're getting the base URI of that document. Now I'm trying to remember what a base URI is. Uh, Base URI. Excuse me. Node base URI. Returns the absolute base URL of a node. What is a base URL? The base URL of a document defaults to the document's address, but can change from the default. Oh, if there is a base tag in the document, you can change the base URL when this is a new document created dynamically. That's very interesting. You can, I forgot that you could do that. You can use base to change what people think your base URL is. Okay. And we've had that support since 1.0. Okay. So we get at the base URL. Sorry, we're going back here. And if we can't find the document, what do we do? Because, I mean, we get the base URI here, but if we can't find the document, then there's this comment here. One of our DevTools browser tests calls register from a content script where there is no valid entry document. We use the window to resolve the URI in that case. So it seems like there's some kind of fallback here where we couldn't use get entry document, so we get the owner of the window, and then we get the outer window. But this only happens if we're doing service worker testing. So this never happens out in the wild. And then we get the doc base URI of the window. Okie dokie. Okay. So let's move on. Let's just pretend we've got the base URL of the document. Then what do we do? Then we are trying to get. We were past this a script URL. One of the things that it doesn't irk me, but one of the things I've noticed about the code within Gecko is that there's like this interchangeability between URI and URL. Universal Resource Identifier and Universal Resource Locator, I think, is what those stand for. And we seem to use them interchangeably. So in this case, we are, or maybe I'm just misunderstanding the finer distinction between the two, but it seems like we use them interchangeably. So we're creating an NSI URI. That's what NS new URI does. This getter addrefs is making sure that like script URI is going to get like properly ref counted. Like this is how you take an out param from a function, an xpcom function that's returning an nscom pointer. Use getter addrefs. It took me a while to figure that out. So we're getting, we're passing in this null script URI, and then there's an out param from ns new URI, which presumably will be the script URI we're attempting to create. We pass in the string script URL. It's just this abstract string thing, and we pass a null and base URI. I guess this is so we make sure that the script URL that we're passing belongs to the document. Like it's part of the family of scripts that can exist within. No, I don't know. A page is like declaring its base, and I guess we just make sure that like the URL makes sense with that base. Let me just take a quick look. Service base URI. IO service. Let me take a look at NSI IO service. New URI, and then you pass in a base URI. The base URI for a spec may be null. If a spec is an absolute URL, this parameter is ignored. So it's a way we can stitch together a full-blown URI given something like /service worker like .js, or maybe just service worker.js. You take that plus a base URI and you can construct the fully qualified URI or URL. That is what I'm guessing is what's going on there. Okay, so we've got a URL to our service worker script. And if things have gone wrong, then it looks like we are going to throw an exception, an invalid URL. Um, that's interesting. I think, and we passed the script URL, so I wonder if this is like some kind of template string. Yeah, it is not a valid URL. That's interesting. And then here we check for slash escape characters in path. Whew. Um, so we get rid of those, I guess. What does this do? Check for a slash. So it takes a string and then we're going, it's a URI. Sorry, it doesn't take a string, it takes an NSI URI and then it's going to query interface it to an NSI URL. So there's a distinction between URI and URL here. And then we are getting a C string. We're getting the file path though, so it's everything after the domain. We get the path, the URL, and then we lowercase the whole thing, and then we look for pound, or not pound, percent sign 2f. If percent sign 2f and percent sign 5c are not found, then we return DOM type error. Uh, what are these? I don't know. We're looking for slash escaped characters in path. Oh, I guess we should be escaping the path separators? I don't think I fully understand. What? Sign C. Oh, like spaces. It's looking for, like, is that what that is? A space? Test escaped slashes. So here's, it looks like this is a test for exactly what we're talking about here. Let's look at the log of this test. And it refers to a bug that's not that old, maybe about a year old. And it's a service worker issue. Depending on the server configuration, it's possible someone to easily break the path restriction. Put a script at users slash something slash service worker.js, then register this. And then I guess that allows the Chrome now rejects slashed with escaped slashes in scope. Oh, if you have any escape slashes, we just ignore them. I hate this path. Anna hates path slash. I think rejecting is the easiest protection against this broken servers right now. Jake Archibald's like, yeah, let's reject. Look at all this cool collaboration between. I think we got people from that's the Chromium team. We got Mozilla up in here. Who's this? Nai blog Hiroki Nakagawa. I don't know maybe that who that person is. I don't know if they work for a browser company. Then Jung Keys, Samsung. Someone from Samsung is collaborating here. That's neat. If you're wondering about this dialogue that keeps popping up, a bug landed in Nightly yesterday, and hopefully Nightlies are going to be respun, and maybe we can maybe when I update next it'll be fixed. Anyways, so we are escaping those things. We escape those slashes, and if things go wrong escaping those slashes, like if we see that the user, we wait. Oh, if we find that there are any. Oh yeah, if we find any escape slashes, so not equal to not found, so you're just some double negatives. So what does that mean is if we find this or if we find this, then we would say DOM type error. Otherwise, all is well. So if all is well, um, we continue. Otherwise, we return null and throw an exception. So in service worker container.register, the scope argument is parsed against different base URLs depending on whether it was passed or not. Okie dokie. So scope URI, that's the thing that's being passed in for options. And if none are passed, parse against the scripts URL. So if there are no, if there was no mscope, then it was not passed, I guess, is being used here. Then we like create a default one. We create a named literal string called default scope. We create a new URI with that default scope using the script URI as the base. And if things go wrong, then we try and get the spec from the script URI that was created. We get the spec of the script URI that we tried to use as the base URI here, and then we throw an invalid scope error if we couldn't properly create that URI. And then so we throw an exception. Otherwise, if a scope was passed, we create a new URI again, same biz, this time we're using base URI to construct. That's interesting. Why aren't we using base URI here? Oh, I guess it's because we're using / script URI. Alright. So we use the base URI here with the value for scope. And if things go wrong, then we do the same thing as up above. We like say, it's no good. And then we also do the same thing, checking for escaped slashes in the path, and we flip out if we find any. So the spec says that the client passed to register. The client passed to register. What's the client in this case? It's the client. What are you talking about? The client. The client. Must be the global where the service worker container was retrieved from. So we're calling the service worker manager, we're saying register. Oh, not to this register. We're talking about the register for the service worker manager. Okay, so there's some overloading of the term register here. This is the global registration. Service worker manager is, I have a feeling, actually the big important piece. Service worker container, just from reading it, is actually quite short and appears to be what we expose to the web. And service worker manager is kind of like the big kahuna in the back doing all the stuff. So we call register on it. We call get owner. I guess that's the owner, the global scope of whatever called service worker. We pass in all of that stuff we just generated, the scope URI, the script URI, and if things go wrong, we throw an exception and no promise. Otherwise, we create, so register itself from service worker manager returns a promise. This is us using getter address again, so it's a promise out param. And then what we do is this little gymnastics here to get a ref pointer that's like a smart pointer, ref counted pointer of the promise called ret, and we're static casting the promise that we got back from register to a promise. So presumably this is not a promise pointer, it's something else. What is it? Promise. What is it? It's an NSI supports. That's what it is. So an NSI supports is like, could be anything. It could be it's anything that implements an XPCOM interface. So we do our work to cast that to a promise, a promise pointer, and then we say we're assigning that to ret. We make sure that it exists, and then we do ret.forget, which is essentially handing off. I always forget how this works, but that's essentially handing off the ref pointer to the counter, to the caller. I think that's what it means. I need to look at the documentation for some ref pointers and com pointers again, because I don't normally use .forget or .take or any of those things. So that's how register works for service worker container. And there's any number of things that we could explore in here. There's like get controller, get registration. Like, what do those do? But like all of them seem to be wrappers for service worker manager. Like they all appear to be calling service worker manager methods, except for is enabled, and some of these like little utility methods. Most of them are calling the service worker manager. So looks like service worker controller is really just a front, just what we expose to the web to register, and the real work is actually going on inside Service Worker Manager. Service Worker controller does a bunch of input validation, like looking for escape slashes, stitching together URIs and stuff, but then hands the work, the real work, I shouldn't say the real work, the work for actually registering the service worker to Service Worker Manager. Okay, so I mean, what we could do is we could keep looking at some of these functions that are exposed to the web, but actually what I really want to do is look inside Service Worker Manager, because that sounds way more interesting. Service Worker Manager is under DOM workers, and there's this like IPDL interface, there is an XPCOM interface to it, and then there's this service, then there's the parent and the child half of the IPC communications pipeline. So like this stuff is, I think, the truly interesting gunk. Whoa, bad formatting. What is happening? That's what I wanted to do. Sort of. I don't know why that spacing is so weird. But so this is where we're going to look next. I'm going to look into each of these one at a time. We've got like, keep doing this for another 45 minutes. Maybe we'll continue next week if people are interested. If this interests you, if this stuff is interesting, please let me know, because I'm just guessing that this is based on the, like, I've heard feedback from people. I definitely read the feedback that people give me on the Joy of Coding rate this episode forms and stuff. And I'm very interested in hearing what you thought of this Better Know a Gecko stuff. Is it useful? Do you find it interesting? Because I don't want to do uninteresting things. I don't want to do unusable things. So yeah, do let me know if what am I dealing with here? Is this a table? Is this a table then? Table properties. Table border. Purple. Ah, I think there is a table down here is what's happening. I need to delete this table. I need to get to the very bottom of this table and delete it. Whoops. Oh, I really don't want to be spending my time formatting this stuff. Ah. What's happening here? This is such garbage. Evernote. Why are you so silly? Destroy. Okay, much better. There. I'm happier about that. Okay, so where am I going to look first? Well, the top of the list is the XPCOM IDL or XPIDL interface definition at the top. So let's start there and see what this thing does. And sometimes there's good documentation inside the IDLs, so let's check it out. Sorry about that little like chunk of time where I was mostly editing my Etherpad note, or Evernote note. Service Worker Manager. So there's a bunch of stuff in here. It's not just the Service Worker Manager. There's these callbacks or interfaces. Service Worker Info. These are all like mostly structs or just like very simple interfaces with one or two methods. But what I like, that's all noise. Let's look at the manager. So Service Worker Manager implements NSI supports, and it registers a service worker. When we call register, it registers a service worker with a script to act as the service worker for scope. requires a valid entry settings object on the stack. This means you must call this from content code within a window. Requires a valid entry settings object on the stack. I don't know exactly what that means. I don't know what an entry settings object is, but maybe we'll figure it out when we look. So let's look at the implementation of register inside Service Worker Manager. As Service Worker Manager, is that what it is? Or maybe it's just Service Worker Manager. It is just Service Worker Manager. So we're looking for a method in here called register. Here it is. Is it just the one? Yeah, it's just the one. So this is carrying on more or less. This is so we did a handoff here where service worker container.cpp called into the service worker manager. It called register here. So what's going to happen? Well, we're in here now. We're being passed the DOM window. That was the owner, in this case, the owner of the script that's calling service worker register. And then it's all those URIs we calculated that we stitched together. And then we're supposed to return a promise as an NSI supports for some reason. So the first thing we do is we make sure we're on the main thread. And I wonder if that's why I crashed before. I wonder if it's possible. Like if we look at that crash I had earlier, like what was that? Maybe let's take a look. Maybe it was because I failed an assertion. Scoped XRE embed start. No, that's not what happened. I did not. This was something else entirely. IPC fatal error happened in the parent process. Oh, interesting. So we do some input validation. We make sure that the window exists. Otherwise, we flip out. And we make sure that we can get an NSPI DOM window inner, which is like the private inner window interface to the window. And that allows us to hopefully get the document that is loading the service worker stuff or doing the service worker stuff. And there's no document, we flip out, return error. We don't allow service workers to register when the document is Chrome. So the document itself might be a Chrome document, like a Zool document or something. We check to see what the principal is on the document, see what rights it has, where it came from. If it's the system principal, then we're out of here. We don't allow it to occur. Then we get the outer window. So we had the inner window before, and we get the outer window. If you're curious to know what the inner window and outer window are, I often have to like reread this document myself, but this document is very handy. Bobby Holly wrote this. Inner and outer windows. Outer window is the browsing context. Think of it as like the tab, or like this browser. You can't see where I'm pointing, but this browser is the outer window, and the inner window is like what the website thinks is window. Yeah, that's kind of what it means. Maybe it's a little inaccurate, but you get the idea. So we're getting at the outer window, the thing that contains this document. We check to see if that outer window has service worker testing enabled, and if so, we hold it in this boolean. And we check to see if DOM service workers testing enabled or service workers testing enabled. That's interesting. Why would we? So we check both this pref and whether or not the outer window has it set. Oh, because it can be programmatically set. That's interesting. Okay. And when is it programmatically set? Set service workers testing enabled. Oh, I think you can call it set service workers testing enabled. You can use it, do it from DOM window utils, and I think we do it in this test here. Set service worker testing enabled. What? Tab actor. Then yeah, we do it live in the midst of a although I don't know why they're not just like flipping the pref in that test and just doing this one off, but okie dokie, they're doing it for one particular window. They can turn it on. Maybe that's for a particular weird case. I don't know. But if testing is on for the scope for whatever reason, then we say that we have authenticated the origin. Otherwise, we actually check to see whether or not the origin from the document is authenticated. I don't even know what authenticated means. This function implements parts of the step through the following algorithm. Powerful features. Whoa. What even is authenticated, is from authenticated origin. Parts of the third. Oh man. Part 3. Algorithms. Is the environment settings object settings a secure context? Given an environment settings object, the algorithm returns secure if the object represents in context of the user agent obtained via a secure channel. For each document in Global's list of workers documents, assert workers must be the same origin with the context that created them. So documents relevant settings origin is the same as Global's. Okay, wait a second. So what do we do here? Is from authenticated origin means, what are we going to do? We're going to get the content security manager. The origin of the document may be different from the document URI itself. Check the principal, not the document URI. We check the principal. While the document is not a Chrome document. And we start by saying it's not trustworthy. We check to see, the check for Chrome document above should mean we never see a system principal inside the loop, so we just add an assertion here. Then we check to see if the origin is potentially trustworthy. We look at the document principal. If it's not trustworthy, we return false. Document principal. Is origin potentially trustworthy? I wonder if trustworthy means like, trustworthy is in, we can, it's like secure. We can call through it using like HTTPS. Oh yeah. Is one of these special like schemes, or if it's like, if the URL looks like something we can communicate with securely and we feel confident about it, that's what it means. Okay. Is from authenticated origin. And if not, then we like, what do? We return this error. And like, if I remember correctly, what did we do whenever service worker container saw an error from register? I see, yeah, just return null to the parent, no promise C stuff. Okay, data URLs though are not allowed. So if the document better have a node principal, check may load. Make sure that the document can load the script URI that's been passed. So we do like this sort of security check. And if not, we say a security error. That's like a content policy thing. Or this is content policy. I don't know what this is. We just make sure that it's allowed to load the script URI. Now we make a decision on content policy whether or not we can do service worker loads, I guess. And if we don't accept it, then we say that it's content blocked. And then we do this check again. Is this the same check? Check may load document principal. Check may load script URI. True, false. This is the same thing. We do this very same thing. Oh wait, no. We're using a different URI. We're using the scope URI now. We were using the script URI before. And then the is origin potentially trustworthy. I didn't even see that. Is origin potentially trustworthy? That's from authenticated origin. Check allows file and possibly other URI schemes. We need to explicitly only allow typo HTTP and HTTPS schemes. I don't even think is really we're allowing HTTP. That's interesting. And HTTPS schemes. No, we just use the AScript URI here for the check since it's already been verified as same origin. This also is a good block against accidentally allowing blob script URIs which might inherit the origin. So wait, I didn't think that is from authenticated origin would return true if it's like an HTTP scheme. Oh, because it might be like localhost or something. I see. We want to allow it if it's like local http:// localhost. I understand. Um, so we check to see if it's HTTP or HTTPS, and if it's not either of the two, then we flip out. It's got to be one of the two. So in this case, what we've got is HTTPS if we're communicating to the outside world, HTTP if we're communicating locally is allowed. Because if we'd gotten this far, that means that it's either HTTPS for the world or we're communicating locally. And now we just make sure that we're using either HTTP or HTTPS and none of the other schemes, no file schemes or anything like that. Then we get the cleaned scope. What does that mean? So we're getting the scope URI, we get the spec ignoring the ref. So the ref is like this, you can have that, like a hash at the end of a URI. So we get everything except that, the entire URI for the scope. And then we do that same thing for script. And then for the window that was passed to us, a window which we eventually turned into the window inner, we query interface that to the global object for that window, the inner window. Then we create a promise. We're creating a brand new promise associated with that global object. And if things go wrong, well, again, when we return a failure, we throw. Otherwise, we've got our promise created now. And then what we do is we create a C string, and we're getting a scope key. So we turn a principal to a scope key. I don't know what a scope key is. My guess is it's some kind of unique identifier for a principal. We cast if the principal is not a code-based principal, then we fail. Otherwise, we get the origin. The origin is the scope key, I guess. And then we add registering document. What is that? So we're taking some scope string and some document, make sure we're on the main thread, and then we have this like weak document list. So weak means that like these pointers may or may not be, like, I don't know if they go away, but they might not be pointing at legit stuff. Hopefully they go away if whatever they were pointing to is destructed. We have this like member m registering documents, and we look up or add the scope, make sure that we have a list, and then for each entry in the list, we get the element and we make sure it exists, an NSI document, and if it doesn't, we remove it. Okay, so yeah, a weak document list. Okay, for each element in the weak document list, there's like this intermediary where there will always be these like weak document list things that have an element at member or a function on them, method on them, and sometimes those will return null, I guess, if the document's gone away. And if so, well, then we remove the element. Otherwise, and here we're making, if the document's already in there, we return. Otherwise, we append it to the list, this weak reference between document and scope. Look up or add scope under M registering documents. What's the relationship here? What's M registering documents? Oh, it's a hash table between a key and a document list. So the scope is the key, and that gives us our weak document list. So for some origin, I guess, like Mozilla.org, there's some list of documents that we can like have registered, and uh, only like you can't have the same document registered multiple times. That's what this does. Um, but if we don't find it, then we add it to the list. Okay, I understand. And then we have what's called a service worker job queue. What? We get or create a job queue. And then we get a, oh my, look at this. Service worker resolve window promise on register callback. Oh, CB equals a new service worker resolve window promise on register callback. And we pass it the window and the promise. And let's see. We get an interface requester. So this thing is like a worker load info interface. I don't know what that means. But we're maybe adding a tab child. I guess this is in the case that we're in E10S world. Then a tab child is like what the document will eventually be rooted at. Or the outer window is eventually a tab child of some kind. Or it's rooted at tab child. Then we create a load group that's separate from yet related to the documents load group. This allows checks for interfaces like inside load context to yield the values used by the document. It will not cancel the update job if the documents load group is canceled. Okay, I don't get it, but okay. But we set notification callbacks on this interface requester. And then, so we're like hooking up a bunch of stuff, is my impression here. What do we use this callback for? Oh, we add it to the job queue. Then we create a job, new service worker register job. So there's this job, and we have the principal, the clean scope, the spec, and the load group. And we have this job, we take the job, we append the result callback. So when this job is done, we will call this callback, which I believe is going to resolve the promise. So this is what's eventually gonna, it's kind of a Rube Goldberg machine. We're gonna, the promise that we got returned from service worker navigator.serviceworker.register is going to be resolved when this job that is being queued in this job queue gets called. Like when the callback gets called, that will resolve the promise. Whew. So then we queue this job of registering, this service worker register job. I think that's what we'll look at next. Then we also do this, like I don't know why we didn't do this earlier. We make sure that we're on the main thread. We do this twice. I don't know how we could have like fallen out of the main thread, but you never know. And then we accumulate this telemetry. We say, hey, we did a registration. Boop, add 1. And then we return the promise to the caller. And return SOK because everything went well. Okay. Okay. What's next? Let's look at service worker register job. This is what's being put into the job queue. This is, I think, doing a lot of the registration again. Like there was a lot of validation, security stuff, and then like a couple things were created and stitched together. But in the end, what we ended up doing was creating this register job, and we passed in all the stuff we created. So I think this job is doing the actual registration. So the service worker job implements the steps in the spec register algorithm, but then uses service worker update job to implement the update and install spec algorithms. So this is the interface for service worker register job, or the class definition. Let's look at the implementation. So the constructor is just empty, but it like just like adds a bunch of stuff to members. It has these members. Oh, it doesn't have members. I thought it had members. Or maybe it does. And those members, yeah, those members are inherited. So where was I? Sorry. Register job. Yeah, sorry. We called the constructor on service worker update job, passing in some of the stuff we were given. And then I guess the job queue is at some point going to call async execute. How's that job queue? What kicks off that job queue? Get or create job queue. A service worker job queue is a queue, obviously. Here it is. Service worker job queue. So whenever you call schedule, what was that schedule job we called before? I don't remember. I think it was probably schedule job. We make sure we're on the main thread. We see we have this M job list. We check to see if we already have that job, and we assert we don't. If the job list is empty, we append the element. Otherwise, then we run the job immediately. Otherwise, we see what state we're in. We assume that we're in a started state, and then we get the last job. If the last job's result callback invoked and job is equivalent to tail job. Interesting. So if job is equivalent to if we've done like something that's so similar and like the last job has had its callback invoked and they're equivalent, then we'll like just give that same result to the current job. Otherwise, we add to the job list. And then we do run job in the first case. So I wonder if run job puts us in the running state. Assert that we're in the initial state. We say give us a callback, and we say start, and we pass the callback on job list 0. Start. What is start? Oh, M job list. What is M job list? It's a service worker job list. So we call start on the first one, and we pass the callback. And the callback is something that is this thing, service worker job queue callback. When the job's finished, we tell the queue that the job was finished. And when the job is finished, we make sure that if the job list is empty, the job queue, when the job's finished, we don't remove it from the queue. So the job list better not be empty just yet. And the job queue should contain the job that was just completed at the in the first slot. And then we do those assertions. If it's not the case, then we return, I guess. Otherwise, we remove the element at 0, and then we call run job again. So run job is going to run the next job, unless the job list was empty, in which case we return. Okay, so it's just a queue of async things where as soon as one's finished, then we kick off the next async thing. That's the job queue. Easy peasy. And it all does that on the main thread. All on the main thread. So the register job, whenever we do the async execute, because I think that's what we call in here for the job queue, async execute? No? Async execute. Service worker job. When we call start on it, we will call the async execute on the job. So it's always going to queue a runnable. Queue and runnables. And then what we do when we register is we see if we've been canceled. Why would we be canceled? I guess a job can be canceled. So if it's canceled, then we abort. We get the service worker manager. We're on the main thread. We get the service worker manager. We get the registration info. So whatever, I guess, registration stuff was passed to register. Oh, no. If that's not true. Get registration is if we are resurrecting an uninstalled registration, then persist it to disk again. We preemptively removed it earlier during unregister, so that closing the window by shutting down the browser results in the registration being gone on restart. If registration is a pending uninstall, then we put it back. Store registration. Pending uninstall is false. So I guess there's like this lazy deregistration that goes on, which we're canceling here. Otherwise, we create new registration on the service worker manager. And we say set registration, registration on the service worker update job. And we update. What's update? Script does not change to perform a byte for byte comparison. We compare. Alright. Stuff. But then we create a new registration in the event that we're not resurrecting, we're not recycling. So service worker manager, create new registration. This stuff we only ever do if we're debugging. I can tell that because of these if defs. What do we do? What do we do? We get the scope URI out. And then we see if there's a registration, and if there is, we bail out, because that definitely, like, that should not be true. The caller made sure of that, but we're making doubly true if we're in debug mode. And what we do is we create a new registration, a new service worker registration info, and we call add scope and registration. From now on, ownership of registration is with M service worker registration infos. So add scope and registration. We make sure that there's an info. We make sure that there's an info principal. Get the service worker manager. I guess because this is a static, as opposed to like a static global. Wait, why are we're getting an instance? Okay, a singleton instance, and that's why the static's not defined on that singleton instance. That's why we have to get the instance, and we get the scope key, which is the origin, I guess. Principal the scope key. Make sure that there's a scope key. And then we have this like M registration infos hash table, I guess. And if there is not such a data in M registration infos, then we create a new one, and we're gonna put that new data in that hash table at that scope key. Otherwise, data is a pre-existing registration. And then what we do now, in either case, we now have data put into the M registration infos. And then what we do is we go through the list of ordered scopes, and we find a scope that matches the current scope. Find the scope that matches the scope that was passed in, and then on data, current scope's length, we put the scope info. Like we on the M infos, we map the scope to the info, A info, service worker registration info, which is different from the registration data per principal. Whew. Brenny says the stack is coming out in the CPP file because you only declare stack class members in the class declaration, not in method definitions. That is absolutely true. Whenever you're doing like, so if this is a static method, add scope and registration, a class static, and whenever you look at the header for service worker manager.h, service worker manager.h, what was this method called? Add scope and registration. Here you can put static. That's where we say this is a static method. It's like a class method on the whole class. It doesn't refer to a particular instance. And in the whenever you actually like implement it, you don't, for some reason, I don't know why C does this or C++ does this. You can't put static in there, which makes it kind of hard to read when you're reading the implementation. You can't be sure whether or not you're looking at a static class method or you're looking at like an instance method. So there's a convention here to like put static in a comment nearby. And yeah, this is the instance, the service worker manager instance. What's the time? It's 2:17. So what do we got so far? So we've got like all these relationships are being set up. I don't really super understand some of the relationships. It's like scopes and infos and registration data, and I guess we should probably look into some of this. Like, so we eventually got here. I'm gonna put a permalink. After much screwing around with job queues and async runnables and stuff, we eventually got down to business doing actual registration. Oh, and there's this like notify listeners on register. So we like, I guess you can register a listener for registration, and I don't know if like that might feed into some of the other stuff that's available for service workers. Okay, so maybe we should look into what a registration data per principal is. It's a struct, an ordered list of scopes for glob matching. Each entry is an absolute URL representing the scope. So it's just a list of scope URLs. Each value of the hash table. These hash tables. Hash table is an array of an absolute URLs representing the scopes. I don't think that's proper English. An array is used for now since the number of controlled scopes per domain is. You know what? Hang on a second. Brenny was so right. I'm just gonna interrupt for a second. I just realized I should play Brenny a sound. I'll play Brenny a sound. Phew, phew, phew. There you go. Brenny, that was for you. Good call on the static. And that's like a losing sound, but I only played it because I just added it to my soundboard here, and I wanted to use it. Even though your total winner in my book's Brenny, I just wanted to play that sound because I think it's funny. There you go. Let's see. So there's a list of ordered scopes, and then there's like these maps, these hash tables from hash keys to registration infos, and then job queues. So this seems to like bind a bunch of stuff together. This seems to be pretty important. Scoped registration. The scope should be a fully qualified, valid URL. Map scopes to job queues, map scopes to scheduled update timers. That seems pretty important. Registration data per principal. That's like, I think, the root struct of most things. Brenny says that the coffee shop Wi-Fi isn't, can't handle my show. I'll have to watch it later. Duh, it's okay. Hope I'm recording. I am recording. Good. So what do we got? We got 9 minutes. 9 minutes. What do I want to look at next? We looked at registration data, and then there's these like infos. Service worker registration info. What's that? Let's look at service worker registration info. That's a full-blown class, so it's got some methods on here. Actually, not really. It doesn't have any methods. It has a destructor, though. And it has some, oh, here's some methods. Service worker registration info, newest. Stop controlling a document. Start controlling a document. Is controlling a document. I wonder if this is like the actual service worker bits. Registration info. The principal, the listener. It seems like there's a one-to-one relationship maybe between service worker registration info. No, am I wrong about that? I may be wrong about that. I was about to say there's this one-to-one relationship with service worker in registration info and registration data per principal, but I think that's wrong actually because yeah, there are all these infos. So maybe the infos is per. So there's like one service worker registration data per principal. There's one of those, and there could be many service worker registration infos. I think there is a 1 to n relationship between registration data per principal and service worker registration info instances based on looking at registration data per principal struct. And I wonder if that's because you can have multiple service workers per principal. That would make sense. Data per principal. You have like, suppose Mozilla.org has like 50 different pages using 50 different service workers. Maybe they'd all have their own service worker registration info. Okay. And so here's what this does. This is the header. There's like a newest, and what it's going to do is it's going to go through, oh, it's got all these different like workers. Installing worker, waiting worker, and active worker. What are these workers? They're service worker infos. Service worker info. Service worker info. Wherever the spec treats a worker instance and the description of said worker as the same thing, we represent the description by this class and spawn a service worker in the right global when required. Interesting, interesting. Curiouser and curiouser. This is a very complicated machine. Complex machine. I don't know. I don't know if we're going to get much more into this. I think I might call it here, actually. Just thinking about some of the... oh, someone's sending me messages. Someone's sending me messages. All right. I think I'm going to call it here. And maybe next week we can go into some of the other... Like, I don't know if we fully understand how registration works. We kind of got down into the guts of it, and we know that these certain structures are being sewn together. I don't think we have a real great grasp on how it's all related. Maybe next week, or next time we do this, this is just like list of important files. I'm gonna have the bottom. Next time, how are, what is, I know the numbers relationship between service worker registration info and registration data per principal, but what are the responsibilities of these structures? There's some other structures like service worker. Well, I know what a job queue is now. Like the service worker info. How about service worker info? What's the responsibility of service worker info? What's the, what do these things do? What do they do? What do they do? What do these things do? Maybe we'll find out next week. Let me know what you thought. Maybe we'll take a break next week and we'll go back to working on bugs, or maybe you want more of this. Maybe you want more exploration of the code. Let me know. So if you look inside the agenda, let me synchronize everything here. If you look at the agenda, there's a link down here called Rate This Episode, and if you click on that link, you can let me know what you thought. If you want more, want me to go into service workers more, I can poke at it. If you want me to start hacking on, but like I can work on this update thing. Sorry, the password manager thing. I'll probably work on it right after this stream. So if you wanted to watch that instead, let me know and I'll do some of that next week. So do click on this link. Do let me know. I'm happy to take your feedback. And I think I'm gonna call it. Thank you so much for watching episode 65 of The Joy of Coding. Let me switch to my screen. Oh, switch to the splash. What do I want to say? Your feedback is so important to me. I really want to know what you want to see, what's important to you. So yeah, do click on that link. I really want to know. I hope this was somewhat useful or interesting. And maybe if you want, we'll go down and do it even more. So just do let me know. Again, thank you for watching episode 65 of The Joy of Coding. My name is Mike Connolly. I will see you next week.
The joy of coding.
Bye.